So hello everyone, welcome to Calculus grade 12. I believe it's class number 19. And today we're going to dedicate our class to your questions and my answers. So feel free to start asking about our past chapters, because in the next class we're gonna start studying next one.
Okay. I have a question on the Unit 3 home assignment.
So let me open the file. Mhm. So what is the page in the textbook?
I don't know the page in the textbook. I just know it. It's on the document.
Okay, so tell me the number of the question. What is the chapter related to?
It's 3.2, I think, and it's question 14 and 10.
3.2. What is it about?
I'm just opening the document right now as well.
In a certain manufacturing process, when the level of production, this one?
Yeah.
Yeah?
Yeah.
Okay. So there, please turn off your mic. So let's enter this question right here. Can you see it?
Yeah.
Yes.
So what is your question?
So I got up to the part. So I found the. Give me a second. Let me just pull it up. So I got the derivative, I think. Yeah. So I found the derivative of the equation. And then I set it equal to 0 and I got x. But x was negative 90 I got. And it says from 1 to 300. And it says what level of production will minimize the cost using that equation. I don't know how to use that.
Oh, so you have quite a lot of questions here. Let's start from the very beginning. So in a certain manufacturing process, when the level of production is X units, the cost of production in dollars, following formula, quadratic equation. Right away, I can say that it's going to be parabola looking upwards, right?
Yeah.
This is the function of cost. I don't know where it's located, but at least it's parabola. What level of production, X, will minimize the unit cost? Unit cost is the number, the cost of the whole production divided by number of products. Keep in mind that the production level must be an integer. Okay. So we should produce it like a full amount of units. We have formula for this, CX, blah, blah, from 1 to 300. That's really important information. So I'm not making a horizontal line. I don't know where it's passing yet, but I can define the range that this function is defined from x equals 1 to 300.
Mhm.
Okay, this is my range. What level of production X will minimize the unit cost? So how do we minimize the unit cost? To make unit cost smaller, we need make price smaller and amount of produced items bigger, right?
Yeah.
So, but we need to have the cost per unit as small as possible, right? There is one more interesting thing to consider, because here we need not to find the minimum cost, but minimum cost per unit. So we're gonna look into minimum and maximum of this function. Okay,
Mm-hmm.
so if we write u of x, if we write u of x as a function, we would replace c of x with this, which is on top, 3000 plus 9x plus 0.05x squared. Keep in mind that this is c of x, while another function, which is u of x, we don't know how it looks yet, and we don't know where it passes, but we gotta look into this function to be the smallest, right?
Yeah.
Because we need to minimize the unit cost, not the cost.
Mm-hmm.
So this is unit cost formula divided by x. This is our final unit cost formula, right?
Yes.
Yeah.
So what I want to do, and I also know that x from 1 to 300. That's why x cannot be 0. If you put 0 in here, yeah, you don't have any, you didn't produce anything. How can you evaluate unit cost of this?
Mm-hmm.
You can't. So if what can I do here? No, first of all, remind me, how do we find, how do we solve optimization problems? It was in your chapter.
You set it equal. You find the derivative, set it equal to 0, and then you simplify like that.
What? No, can you answer me how we find unit cost? What is this? Oh, not unit cost, but
Oh.
optimization problem. How we solve them in general.
Um. Second.
First thing we need to like define the function, like the. Actually, I'm not sure.
So what were you trying to do with c of x?
Oh.
You were
You.
trying to differentiate it, set it equals to 0,
Yeah.
right?
That's what I said.
But so for cx equals 0, it would be horizontal tangent line, so the minimum of this function,
Mm-hmm.
right?
Mm-hmm.
Yeah.
But this function is not parabola.
Which one?
This.
Yeah, it is.
No, it's not. Because we divide by x.
Oh, okay. Oh, yeah. Oh, yeah. Sorry. It's a reciprocal.
So let's try to do the same thing. Let's differentiate it and see what happens next, right? How would you differentiate such a thing?
You would use the quotient rule.
Exactly. Let's see what it gives us. So u prime of x equals, what is the formula for quotient rule?
F of x times g prime of x.
Okay, so f of x, let's go step by step. Here is the weird, I cannot copy paste it, then I just write it again. So 3000 plus 9x plus 0.05 x squared
Times g prime of x. So it's 1. Subtract g of x. So x
So
times
9 plus 0.1x times g of x. Am I right? Divided by x squared. What would you say about it?
Yeah.
So the next line for us. You didn't try differentiating this?
No, because I
Mm.
thought we had to solve for x at first and plug it in right away.
So the problem is if you solve C of X, let's say you find this point. In this point, I don't know where it is. It could be here. It could be when X is, for example, 50 pieces, or when we made 10 pieces, right? We don't know right now where it is, but you find this and you have cost, right? Cost of production. But you don't know if you produce more part right here. Does the cost of production grows just a little bit while you produced much more parts, for example? Do you see this?
Mhm.
So this minimum would not be a thing that gives you optimal U of X. So let's keep solving. Now I would like to open the brackets. I'm gonna have 3000 minus 9x plus 0.05x squared, subtract 9x, subtract 0.1x squared, right? Guys,
Yeah.
Yeah.
so next line. Now I wanna find common, same terms, common terms.
I got 3000 subtract 0.05 x squared.
Here's plus 9x, right? So 9x is annihilated, and subtract 0.05x squared divided by x squared.
Mhm.
What would be the next step once we found this derivative?
Would you plug it back into the
No, in when solving optimization problems,
would you simplify this? Or can you simplify it anymore? You can't. A second. Um, you would find the zeros.
so we would say derivative equals 0, right?
Yeah.
We need to find the minimal value of this, right?
Yeah.
To make it as small as possible. So, okay, let's try to plug in equals 0 in here, right? Right away we see that x cannot be equal to 0. So it means that upper part 3000 minus 0.05 x squared should be equal 0, you say, right?
Um,
Because for me it doesn't look right. We cannot make it equal 0 because we can produce the most of 300 pieces.
no, I said we have to find the zeros. I didn't say set it equal to 0. Like find the critical points.
Okay,
So, you would. Would you set that equation equal to 0, move it to the left side, and then divide one side by divide 3000 by 0.02 and then square root it to find the answer.
Sorry, can you say it once again?
So if you set 3000 subtract 0.05 x squared to 0 equal to 0, you could bring over the 0.05 x squared to that to the left side. Divide 3000 by 0.05, and then you have x equals some number, and you square root it to find what x equals.
So, yeah, basically, it all sticks into finding this critical points or critical value, right?
Yeah.
So let's solve it when this equals 0. What would be your answer?
I'm doing that right now. $244.9, so 245.
Should I double check it?
You could,
Because you have x squared.
yeah.
So you're gonna have two solutions for this quadratic function, but you're gonna say that negative solution is not appropriate because we're talking about amount of produced pieces, right?
Plus or minus 245.
Plus 245. 245 times, let me check. 245 times 245 times 0.05 doesn't equal 3000.
Well, because I did 3000 divided by 0.05, which is 60,000 or
Huh.
60,000, and then square root that, or not square root it. Yeah, square root it.
And you got 245?
Yeah.
You can't, because right now I'm multiplying 245 by 245 and I'm not getting 60,000.
Well, I rounded it. It's 244.9 something something.
How can you how can you round it?
I mean, it's because it's very, very, very close to 245.
Mm,
244.
okay, so we would say close to 245, somewhere in this range, but before this point, right?
Mhm.
245. And you're right, exactly, that we can round it up because here, mind that the production level must be an integer. That's why they wrote it here. So in this stage, you wouldn't take a fracture as for amount of produced parts,
Mhm.
right?
Yeah.
So great, we found the critical point 245. We also know that we're gonna have another critical point at negative 245, but we're not interested in it.
Mhm.
So once we have this value, what do we do with it?
Do you plug it back in for x in the original function?
So I believe if you plug it into original function, you're gonna get a cost, right, of this whole production.
Mhm.
So now let's actually do the following thing. Let's substitute this value not in the cost function, but into unit cost function. And tell me what are you getting?
So do I just plug the number back into the equation?
Yes, into this equation.
The rounded one or the full one?
What?
The rounded number or the integer?
Integer.
Okay. It's 33.5 around there.
Mm-hmm. 33.5. Okay. But and I would like you to think why it turns out the 245 looks like the best option for us. How unit cost function would look like. So this is the answer, 245.
Yeah. What was the question?
How
Mhm.
we can analyze this case without exact solution but just looking at this. You said this is what type of graph?
Reciprocal?
Looks like it. Can you plot it on the drawing, how you think it would look like?
You know, like roughly like this. And like down here like that. Oh wait, actually, it would look something like that, but
And that's what I'm trying to, yeah, exactly. It's gonna look something like this, let's say. But in fact, I think 245 is because this is the point where this graph turns
Okay.
horizontal.
okay.
After this point, unit cost is not getting smaller. Or getting smaller, but not much smaller. You see, it's gonna try to approach this horizontal, the x-axis. It will try, because we have horizontal and vertical, basically asymptote.
Yeah.
And this line is gonna turn horizontal after this point, basically, almost horizontal. And it means that if we produce more units, we're not going to reduce the unit cost.
Okay. So is the final answer just
To
X?
to
equals-
x equals 245.
Okay, I got it.
You see, at the beginning, if we produce like only one piece, our unit cost is ridiculous, super high, right?
Mhm.
The more units we produce, and you can see it here, the more x is becoming, the more, first of all, impact it has into this price. Because before x turns into somehow significant amount, 3,000 is going to be decisive aspect here. No matter like you produce 2 pieces, 3 pieces, each one of them gonna cost 3,000. If you produce one piece, it's gonna cost 3,000. But you increase amount of produced pieces, price per piece, per cost of production is not growing so fast, right?
Mhm.
But ratio unit cost is decreasing faster than the cost grows.
Mhm.
So good example. I hope you understand it now.
Question 10.
Maybe Yusuf has any questions.
I did have one before, but you actually explained it like right now.
Mm-hmm, mm-hmm. Perfect. No, so sync while we still have time. But once you run out of questions, we can finish the class because I didn't prepare anything for you today.
Question 10.
Okay. Let me look into it. What is a truck traveling at X km per hour?
It is if it's very similar to this question, then I don't need help, but I think
Wait,
it is.
which one? Which one? The in a truck traveling, right?
I think so. It's that one, yeah. And it gives you a function.
Oh, can you read the question?
I don't have it pulled up. I'll pull it up right now.
What function do you have? 1/4 brackets 4,900 divided by x plus x?
Ooh, I have to pull it up, sorry. It was similar to this one, but I just gave you like a harder thing. Here. Very good. Okay. It is a truck, yeah, a truck traveling, and it gives you the 1/4 times 4,900 over x plus x.
Sorry.
The truck is traveling at x kilometers an hour.
From 30 to 120, right?
Yeah.
Oh. Oopsie. Can you see it now?
No. There we go.
So. Okay. In a certain oh wait. A truck traveling at X kilometers per hour, where X is between 30 to 120 kilometers per hour, uses gasoline at the rate of Rx liters per 100 kilometers, where Rx, so function Rx shows us the consumption per 100 kilometers. Rx following function, if fuel costs 1.15 liters per liter, what speed will result in the lowest fuel cost for a for a trip of 200 kilometers? What is x in this function? X is speed, right?
Yeah.
So tun, tun, tun. So this is consumption, this is uses gasoline at the rate of this this much liters per 100 kilometers. Okay, so this function is gonna give us, we know that we're gonna make a 200 kilometer trip, right? So we're gonna use 2 times amount of this fuel if we go at specific speed. So we would like to know the lowest consumption per 100 kilometers that we can get. Because fuel cost, what it consists of? It consists of number of liters times price per liter, right?
Yeah.
This is our price per liter. And basically this is gonna be, this times 2 is gonna be amount of fuel we're gonna spend. Right?
Yeah.
So if price per fuel is not changing, it's constant, we would like to find the amount of fuel, the smallest amount of fuel we can spend. And that's how we minimize this cost. Make sense? While this is constant value, we cannot adjust it.
Okay.
We can change only amount of liters that we use. So in order to make cost, this is cost. Amount of liters times the price per liter.
Okay.
So we need, in order to make costs minimum, we need to reduce the consumption to minimum. And to
Okay.
do that,
We have to,
we need to find minimum of Rx. And then that's gonna be solution. We don't even need to multiply it by 2.
so if we find the derivative of it and then find the zero,
Yes. But you gotta compare which solution will match you, because, for example, from what I see here, most likely you're gonna get a quadratic function, and in order to solve it, you're gonna have like 2 roots, and one of those roots is gonna be negative, or maybe not, who knows.
okay.
But you need to analyze those critical points,
Mhm.
basically critical values, if you prefer. So do you want to solve it?
Yeah.
Okay. 1/4 times 4,900 divided by x plus x. This is Rx. Now, next step for us is to find the derivative of Rx. And here I have basically it's even easier. It's just a sum rule here. Why, you may ask me? I'm gonna tell you. Because 1/4 is constant. 4,900 is constant times x to the power
Oh,
negative
yeah.
1 plus x. So it's simply sum rule. So, and we need to differentiate this, right? And if we differentiate it, we keep the coefficient untouched because it's outside of the brackets. Inside, it's just coefficient, right? Now we need to find derivative of what is inside. Derivative of first term would be 4,900 divided by minus 4,900, right? Because I bring this -1 in front. Divided by x squared, or x to the negative 2. Plus how much?
One.
Okay. So where else can I do here? Interesting thing I can see that hmm, oh, tell me how this could be equal to 0.
You. That could be equal to zero, that equation?
Yeah, how this could be equal to 0. Basically, we don't care about coefficient because coefficient doesn't affect whether it equals 0 or not.
You could. Actually. Would x squared equal 0, a negative, no, yeah.
So let me help you. To solve it, I just write it out as this. And see, okay, equals 0. My next step would be bring this to the right and get rid of this, or wherever.
Okay.
Or minus 4,900 by x squared equals
negative.
-1.
Yeah.
So when does this equals -1? When x squared equals its nominator.
Yeah.
When the nominator equals nominator by module, we're gonna get 1.
Mhm.
So what I can say that x squared equals 4,900. And x equals
70.
70. Beautiful. Why not -70?
Because you can't. Oh, it could be. Wait.
You're right, you're right. I won't trick you. It can be negative. It would mean only one thing, that we're going backwards.
Yeah. Okay.
But in this case, we said that we're only going forward and from 30 to 120 kilometers per hour.
Okay. Yeah.
So 70 would be the optimal speed to optimize the cost of a trip.
Mhm.
So this problem is constructed for you not just to find the first derivative of simple function, right? Because you can do that. This problem is constructed for you to flex your brain, make it more flexible in problem solving. Because if you read this question once again, the first thing I can realize right away, they give you a lot of information, right? Speed range from 30 to 120. You don't even need it after all, but they give it to you, right? They give you consumption per 100 kilometers, cost of fuel, and 200 for a trip of 200 kilometers. Why didn't we use 200 kilometers?
I don't know.
Because because what is the lowest total cost for the trip? That's why we didn't use it. That because question is what is the lowest cost, not what is the optimal speed.
Okay.
You see it? So
Yeah.
now what you gotta do is substitute 70 into where?
The original equation.
R of x. And does that's it?
And then solve it.
No, and one more thing.
What do you mean? Oh, you times it by 2?
Yes, because this is for function only per 100 kilometers.
Mm-hmm.
You have to keep in mind that you have to multiply it by 2. Yusuf, do you have any questions?
No, I'm working on another question right now to see if I get stuck anywhere.
Okay, okay. Have you solved this one?
This one, no, I was just following with you guys.
Okay, okay. So make sure you include it into your home assignment solutions.
Okay, yeah.
Well, I'm solving the R70. So 17.5 times 2.
Sorry. But it should be much easier for you to calculate it. First of all,
35.
4,900 divided by 70.
70 plus 70 equals
140 divided by 4 and times 2. So 140 divided by 2.
70. Yeah, 35. That's what I got.
Wait.
Well, 70 times divided by 4. Wait.
You can skip this divide by 4 step if you multiply by 2 first. So you're gonna divide by 2 only.
Oh, I'm multiplied by 2 at the end, so I got 35 as my final
So
answer.
that's why I'm saying you should modify this function first. And I'm not saying this because only because I want you to modify it first. Because in future, when you're going to solve more complicated equations and you do not include all the parts of the equation first, because imagine if instead of 200 kilometers, I would say they would say X kilometers,
Mhm.
right? Then your multiplier would be X divided by 100, for example. Am I
Yeah.
right? Because X is a number of kilometers and 100 comes from consumption per 100 kilometers.
Okay.
Because what if I ask you, what should you do if I travel 50 kilometers? How would you solve this problem?
Oh, I divided by 2.
You divide it by 4 or 2.
Yeah.
Huh?
2.
Great, right. So the answer, what is the lowest total cost for the trip?
$35.
What?
35.
How? If I have 70 here plus 70 here, 140 divided by 2 is 70. So I spent 70 liters and cost per liter is 1.15. That's why they give you cost per liter, because they want you to know total cost for trip, lowest total cost.
Mm-hmm.
So 70 times how much? If I spend 70 liters
Yeah.
to find the cost of the trip, I need to multiply 70. Look here. Remember, total cost equals amount of liters times price per liter. Make sense?
Yeah, so what would the final answer be then?
70 times how much?
2.
No. What is the answer for this one before
seven-
multiplying by 2?
17.5.
No.
Wait, did I do the calculation wrong?
Yes. We just figured out that it's
Oh
going to
yeah,
be
I multiplied.
it's going to be 32.5. Oh no, sorry. It's going to be 35.
The final answer?
No.
Yeah. So that's what I got. So what the final answer?
35
70?
times, so 35 liters per 100 kilometers,
Okay.
right?
Yeah.
I traveled 200 kilometers, then how many liters did I use?
70.
70. What is the price for gasoline?
$7.
Where did you take it from?
Uh,
Not in the gas station, in the question, in the problem.
yeah, the X.
No. The price of fuel is giving to you.
Oh, okay.
You see it now?
Yeah.
How much is it?
1.15.
And now you multiply 70 by 1.15, right? Alan?
Yeah. Come on. Why do we multiply by 1.15?
Because that's price per liter.
Okay.
And we are asked what is the lowest total cost for the trip?
So
Cost
70,
of the
70 is the liters we used.
liters, yeah. 70 liters we spent for 200 kilometers.
Okay, and then you multiply it by that to get the cost per liter.
No. Then I multiplied by cost per liter to find total cost.
Okay.
So let me talk you through it again. First of all, what we did, we figured out formula for cost of the trip, right? It was the first thing we did.
Mhm.
Cost of the trip depends on how many liters we use and how much liter costs, right?
Mhm.
Then we had to solve optimization problem to find lowest rate of gasoline usage per 100 kilometers, right?
Mhm.
We found that at speed of 70 kilometers per hour, we would use least amount of gas, right?
Mhm.
So we're gonna use least amount of gas per 100 kilometer. So if I'm asked what is the lowest cost of a trip for 200 kilometers, I'm gonna say, okay, for 200 kilometers, I have to spend 140 liters. If I spend 70 for, oh, sorry. So I skipped the step. Once I found my speed, my optimal speed, 70 kilometers per hour, I substituted into formula to find R, or amount of liters that we spent for 100 kilometers, right? Using this formula, I found out that I spent 35 liters per 100 kilometers, right? Guys,
Yeah.
it's clear, right? What I'm explaining right now. We're
It's
just going
fine.
through the solution. I found that I spent 35 liters per 100 kilometer. Then I multiplied by 2 to find how many liters I spent per 200 kilometer. It turned out to be 70. It means, and now I know I spent 70 liters. How do I calculate how much money I need to buy it? I multiplied by cost of the gas, and it's $1.15.
Okay, so 70 is liters.
70 x is kilometers,
Okay,
and we have 70 kilometers per hour.
yeah.
And
And-
we have 70 liters for 200 kilometers.
Okay. 70 liters per two.
No, you shouldn't write it just like that. You just need to write that number of liters that you're gonna spend for 200 kilometers equals 2 times Rx. And then you solve it, right?
Okay. Yeah, I got it. I understand
The,
it.
this equals number of liters that we spent for the trip.
I got it.
Any more questions?
Well, I have some a bit, just small ones. If nothing. Okay.
Sure, go ahead.
Same for unit the home assignment thing for unit 3, lesson 3.
Yeah.
It's just
Mm.
the perimeter questions in the beginning. I know how to solve it. I just don't know like the proper algebraic way
I sorry, I don't know what you're talking about.
on the same document.
No, just tell me the number of the problem.
Number 5,
Number 5, unit 3.2,
3.3.
3.3. Number 5, a rectangle has a perimeter.
Yes. So I
Yes.
know how to solve it. I just don't know like the proper algebraic way.
Okay, I will try to explain as much as I could.
Like something very brief because I don't need. I understand the concept.
No, algebra. If you cannot solve it in mathematical way, I'm not sure if you understand it then. Because mathematical way should be the only way. I remember, I understand what you're saying about, because when I was at school and teacher asked me what is the right answer, and I say it's obvious, 5. But why it's 5, I cannot say.
Okay.
So rectangle has a perimeter of 440 centimeters. Rectangle, right? So we don't know what the length of the sides. We know it's just rectangle. It could be rectangle like this. It could be rectangle like this, right?
Yeah.
I actually like this drawing. Wait. Let's say my rectangle looks like this. I'm giving that my perimeter equals 440 centimeters.
Okay.
Perimeter. What is perimeter?
The
Perimeter
added up.
equals 2 times A plus 2 times B.
Yeah.
A and B. I know that this equals to 440.
Mhm.
What dimensions will maximize the area of the rectangle? What is area? Area is A times B. Am I right?
Yeah, yeah.
So what dimensions will maximize the area of the rectangle? So we want to make this as big as possible while we are limited to 440 centimeters perimeter.
Mhm.
Any ideas? So now we know we have two formulas basically.
Well, I got 120 and 100.
Pardon?
I got 120 and 100.
120 and 100. You just substituted for A and B and right?
Yeah,
Yeah, not the best way to solve it.
I know, that's why it didn't really.
So I want to maximize the area of the rectangle. When I have problems with questions, I just refer to the chapter that this question refers to, okay? And for best thing to look at when you're solving problem is what, in summary, what you need to know.
Pardon me?
First thing first that I like to do is just refer to previous chapter, go to list of what we need to know in order to solve it.
Mhm.
So here it says algorithm for solving optimization problems. Understand the problem and identify quantities that can vary. Determine a function in one variable that represents the quantity to be optimized. So we need to, first thing that we need to do is to bring it to one variable, right? And now we have two variables.
Mhm.
How do I, this is the, no, first thing, understand the problem. I understand that my perimeter is like exact number. So I have limited values for A and B. Okay. I also know that I have function of area because it's simple. For square, it's length by width. And I need to optimize this formula, right? For area, not for perimeter. Perimeter is constant. I need to optimize the area, but another problem, I'm working with rectangle, not with the square. So rectangle, because square would be fixed with perimeter of 440, right? It would be only one possible shape. Guys,
Mhm.
Yeah.
that's why I'm working with rectangle. And I would like to do it so that I have only one variable. I don't need A and B. I want only A or only B. And another funny thing to notice, that these two functions are connected. They depend, like they both depend on same variables.
Mhm.
When we substitute some values into perimeter function, we substitute the same values into area function. So it means A and B in the both of them are same, right? So if I find this B, I can substitute it here for this B. So how can I find B on top? And it's pretty simple as that. I have function 2A plus 2B equals 440, right?
Mhm.
I would like to know what B equals to. Okay, so to find B, I bring 2A to the right, sorry, and divide by 2. So I'm gonna have 240, subtract 2A divided by 2 equals B, right?
Yeah. And then you do the same thing for A and you plug it.
No, wait. Let me finish. So I simplify it and I'm gonna see that 220 subtract A equals B, right? Now I take B, this B, and substitute it into function for area, right here. And now I changed my function of two variables to function of one variable. I'm gonna have A times 220 subtract A. Any questions?
Wait, sorry, wait.
No.
Oh, okay, no.
Have you ever done this before? Have you ever substituted
Yeah.
one variable to another in order to solve it?
Yeah.
Because you are not able to solve problems with two variables yet.
Yeah.
You're gonna do it later in your studies. So this is my new function for area. I simplify it. I basically open the brackets and I can see that I have quadratic function, right? And I
Mhm.
just need to solve it for 0 in order to find critical points. And here it's
Factor out an A.
button.
You factor out an A.
Yeah. Mm. It's gonna be minus A plus 120 equals 0. Let me check if I didn't make a mistake before. 2A plus 2B equals 440. Bring to the right. Divide by 2. Oh, looks right, man. Looks just right to me.
Yeah.
Okay, so my solutions are 0 and 220. Hmm?
That can't work.
Yeah, because then I'm gonna have just a straight line without two sides.
Mm.
Why didn't it work? Because we didn't find the derivative. It's as simple as that. We just simply substituted b for a
Mhm.
and we solved it. But no. Area is gonna be 0 when a equals to 120, and that's true. Because if one side equals to 120, we're just gonna have a straight line and
Mhm.
another straight line next to her. So perimeter 440, but area is 0. Make sense?
Mhm.
So we delete this step because we forgot one crucial thing. No, this I need. I'm going to find derivative of this.
Okay.
This does not equal 0 just yet, but derivative of this equals 0, right? So I'm gonna have negative 2a to the power 3, or no, to the power 1, right? Plus 220 equals 0. Is it simple?
Yeah.
Derivative of sum. One power rule I used here. So next step, a equals negative 220 divided by negative 2, or a equals 210, right?
Yeah.
Centimeters. And now I know length of the a side is going to be 110. And to find b, how do I do it? Guys,
So, yeah.
how do I do it?
To find B,
Yeah, to find b.
would you have to do the same thing but substitute, or it's same
No,
thing?
I will just plug in a
Oh
into
yeah.
this formula I came up with. I already solved it for b, but now I know a, so I stick in it into this formula and I get that b equals to 110 again.
Mhm.
And this is proof that square has a greatest area with least perimeter between rectangles. You see, basically what it says to you, your lengths and widths should be the same in order to have maximum area, right? Guys,
Yeah.
I don't feel like you understand.
No, I understand. I'm just copying down on my book.
Mhm.
I remember doing stuff like this.
You know what is the geometrical object that has least area to its perimeter? Oh no, least perimeter and greatest area ratio.
The least perimeter and greatest area, is it a rectangle?
That's a circle. The circle is the best shape in the entire galaxy that every substance is trying to achieve. Because when you have a circle, you maximize your area and you minimize your perimeter. That's why drop of water is round. That's why in movies, when some liquid is spread into the space where there is no gravity, right, and no atmosphere,
Mhm.
the the liquid turns into bubble,
Mhm.
while nothing is basically forcing it to turn into bubble. But that's how we see it. In fact, internal bounds in this basically piece of water, they try to make water of a round shape because that's how they spend least amount of energy. Or basically optimal volume you get per your perimeter.
Mhm.
It's really fun thing to study.
Oh, so it's 110, but isn't that a square?
Pardon?
Isn't it a square then, what we're making?
Yes, that's what I told you. And you said you understand it.
Oh,
Square, isn't square a rectangle?
no.
It is. Rectangle is not square, but square is rectangle. Not every rectangle is a square, but every square is a rectangle. Rectangle is a geometrical object that has four corners and all of them are 90-degree. And square is a rectangle that has equal sides.
Okay.
And what I tried to tell you here, that now you see that when you have same sides, your rectangle is going to have the greatest area while maintaining same perimeter as some other rectangle. For example, these, let me show you. You see, I have a red rectangle, right? And now I draw blue square next to it. You see? Or let me be more precise. It would be something like this. Imagine if this is a rectangle of perimeter 440, then this is square of perimeter 440. Which area looks greater to you?
Look greater?
Yeah. You cannot say it right away, right?
No.
But in fact, square with the same perimeter is going to have greater area than rectangle with the same perimeter but not equal sides.
Okay.
So I believe that's it for today, guys. All right.
Okay.
Thank you for coming to the class. It was nice talking to you, solving these problems. I hope I helped you.
Mhm.
Yeah.
So yeah, have a good week, guys. See you on Friday, right?
Yeah.
Get
Have a
ready
good
for
day.
the new topic. Good luck.
Okay. Thank you.
Bye-bye.
Bye.